That's metric conversions. The other type of conversion is between English and metric. And the process is the same no matter which direction we're going, starting with English and ending with metric or the other way around. The process is called dimensional analysis. To do dimensional analysis, you have to have an equivalence. This is an example of an equivalence. 1 inch equals 2.54 centimeters. And what it does is relate the two units to one another. It tells me 1 inch contains 2.54 centimeters. What this equivalence allows us to do is convert between the two units. I can go from inches to centimeters or from centimeters to inches with that one equivalence. Now, I'm often asked, do I have to memorize all these equivalences? Not in my class. There's never been a point in my life where I've had to pull an equivalence out of my head without being able to look it up. So I'll provide you with equivalences. Typically on a test, I give you an equivalence bank. At the top of the page will be all the equivalences you need to solve all the math problems. So you don't have to memorize these numbers for me. You may have to for other teachers. Let me show you how to use this, how the process goes. And it's going to be a 3-step process for us. The first step is going to be to write down our given. Whatever number I give you to convert, start with that. Write it down first. Then you'll draw in your multiplication sign, your fraction bar, and your equal sign. You'll lay the equation out. Works like a road map. Tells you where you're going. It's telling you what you're going to do next. So draw these in second. Then we wrap the equation up by taking the numbers from the equivalence and putting them in the fraction, using that fraction bar, setting up our equivalences as a fraction, making sure that the given unit is on the bottom. That is key. When we take our numbers out of our equivalence and put them in the fraction, we make sure whatever unit we're given is on the bottom of that fraction. Reason for it is simple. Unit cancellation. We got to make sure that our given unit cancels out. When I was in high school, when I was taking chemistry, when we were learning dimensional analysis, my teacher always said it's about unit cancellation. It's about unit cancellation. If your units cancel, you know you did it right. But I didn't pay too much attention to them. So whenever I had a dimensional analysis problem on a test or a quiz, I was really just guessing what I was doing, and I got it right about half the time. It wasn't very fun. Now that I'm older, now that I'm teaching this, I understand what he says perfectly. I understand what he meant perfectly. If we put this given unit on the bottom when we set up our fraction, our units will cancel. We'll be able to see the unit cancellation. We'll be able to know we've done it right before we ever turn in that quiz, before we ever turn in that test. Let me show you an example. We're going to convert 3.7 inches to centimeters. The equivalence isn't up here, and it's not because you have to memorize it for sake of space. It'll be up there at the end. We start by writing down the given, the 3.7 inches. That is the first thing that goes into our equation, so write it down first. Once we've written down our given, we draw in the multiplication sign, the fraction bar, and the equal sign. That's our road map. It tells me I've got some things to fill in. I need to fill in this fraction before I can fill in my answer. Lay it out. Again, I'm often asked, do I have to show all my work? Answer is, if you want to get it right, you'll show your work. If you want to get it right every time, you'll put the equation down. When you're converting between inches and feet, that's pretty easy. We've been doing it most of our lives. We know there's 12 inches in a foot. We know if we have to convert 1.5 feet into inches, we're going to multiply by 12. We're used to it. It's something that we've done over and over again, but we haven't gone inches to centimeters quite so often. We haven't gone between liters and gallons quite so often. So if we want to know we're doing it right, if we want to know that our answer is going to be correct every single time, we draw out the entire equation. It only takes a couple of minutes. Third and final step before we can solve this is to take these numbers from this equivalence and put them into our fraction. And again, remember, given unit on the bottom. Our given unit is inches. So when I take these numbers and write them into the fraction, I got to make sure inches are on the bottom. So that's where I start. I take my inches, I put them on the bottom. This is for unit cancellation. When I do the math, these inches will cancel each other out, and I'll know I did it right. The other number, the 2.54 centimeters, will go on the top. Again, all I did was take the numbers out of my equivalents and put them in the fraction. In doing so, now I have a complete equation, and I'm ready to solve. When it's time to solve, best place to start is with the unit cancellation. Unit in the numerator, same unit in the denominator, those cancel out. When I look at this equation, the only unit left is centimeters, and that's a great thing because that's what I was asked to find. Now solving this, you can take this and simplify it. What we do, we get 3.7 inch, well, the inches cancel out, so we'll take those back off. We get 3.7 times 2.54 centimeters equals, yeah, we just took the 2.54 divided it by 1 to simplify it. We canceled out our inch units, so I remove those because, again, we're simplifying. To solve this, we just multiply those two things out. 3.7 times 2.54 is, calculate our answer, 9.398. Only unit left in our equation is centimeters, so that will be the unit we put on our answer. Again, rounding always comes up. My students ask, where should I round this? And it's physical science, so we're not into significant figures here, and it really doesn't matter to me. You can write this whole thing down. It's not that long, but sometimes, you know, it fills up the whole calculator screen. And I'm not going to go into significant figures because I don't want to confuse anybody. So what I always tell my students is if you want to round, if you've got a full screen full of numbers, then at least leave me one number after the decimal point. Round it to the tenths place. That way I have a better idea of whether or not you did it right. And write down the whole thing if you want. Round it to the tenths if you want. It's up to you. You'll learn about significant figures in biology, chemistry, physics when you take those classes later on down the road.